All right, hello everyone, this is Mr. Crozier, and I wanted to help you with problems 15 and 17 for your proofs. So here we go. Problem 15 says, given that PQ, and that's this segment here, bisects this angle SPT, and that these two sides are congruent, prove the triangles are congruent. So let's go ahead and start right here with our given. You're going to want to write all of this stuff in this given box and put given. And now what we're going to do is we're going to go about proving that these triangles are congruent. This left one and right one are the same, and they very much look the same, so we need to prove it. And on all of our proofs today, the final step is the SAS theorem, which means if we have a side and an included angle, then it's congruent. So we just have to get to this. All right, so let's go ahead and see what we have. Well, first statement we have is that SP, actually I'm going to go ahead and rewrite this up here again, is TP. They're the same thing. I'm going to mark them right here. This side and this side are the same, so that's a side. We have a side together. This side and this side match. So we have an S, and a lot of times I write it over here too. All right, now what about an angle? Well, what about these two angles? They're marked congruent, but how do we know they're congruent? Well, we can say angle SPQ, that's this one here, is congruent to QPT. And how do we know that these two angles are congruent? Because if an angle is bisected, then the angles are congruent. That's what it means to bisect. When it says it's bisected, that means this angle is cut perfectly in half and they are congruent. So we have an angle. So look at my proof. I've found a side that's congruent. I found an angle that's congruent. And now let's find another side. And both triangles share this middle side right here. So PQ is the same as QP. And that's called the reflexive property. Like you're looking in a mirror. The left side and the right side, they're the same. This side is congruent. So both triangles have sides match, angles match, and this side is in both of them. So in the triangle we have a side, angle, side. We have two sides and an angle included. So we can skip this step right here and say angle SPQ is congruent to TPQ. And again, this first information always goes in the first box, and this last information always goes down here. And the only reason we have on this lesson is SAS. All right, so let's go ahead and do the same thing here. Well, we can take this line and write it here, and we can take this bottom line and write it right there. Triangle ABC is going to be congruent to EDC. And we know the reason. There is no other reason right now. In this lesson, this is the only reason. All right, so let's see what we have. C is the midpoint of these big segments. So here's A to E, and C is the middle of that. And here's B to D, and there's the middle of that. So what can we say? Well, I know that AC is congruent to CE. This side and this side, they're congruent. Well, how do I know they're congruent? Well, if midpoint, I'm just abbreviating here, if midpoint, then two congruent segments, right? That's what it means for something to be in the middle. The midpoint means that it's the middle, exact middle. And then if I have these two, well, what about these two? BC is congruent to CD. And again, same thing. If you have a midpoint, then you have two congruent segments. All right. Take a look at what I have. I have two triangles, triangle 1, triangle 2. I have this side's congruent here and this side's congruent here, so I have two sides and two sides. Now all I need are an angle that's in the middle. All I need is this one to be the same as that one. All I need is angle ACB, let's see, A to C to B. to be the same as D to C to E. Well, are they congruent? Yes. How do we know? If vertical angles, comma, then, oops, let me fix that, then congruent. Again, don't worry about the perfect wording over here on the right-hand side. Just try and give some good reasons here. And the reasons usually are if, then. If a midpoint, then the segments are congruent. And we know this one, right? If you have vertical angles, then they're congruent. All right, let's see what we have in our drawing. I have a side and a side with an angle in between. I have a side and a side with an angle in between. Now I did it out of order here, but that's fine. It's still two sides, and this angle is really included in between those. And once I have side, angle, side, I know the triangles are congruent. All right, when you do problem 16 and 18, you're going to go through the same steps, look for the same thing. This is our only theorem. We only have one right now. Later this week, we'll get to more, but right now we just have one theorem. Side, angle, side.